Yeah, I reiterate, thanks very much. Thanks for being the guys who did come back from lunch. So this afternoon we're going to have a bit of fun. This is going to be a live demo, multiple bits of software and hardware involved, so anything can go wrong at any point. So it's got the danger factor, which should keep everyone a little bit awake. Today I'm going to be talking about CrateDB. Who's at least heard of CrateDB? Who'd heard of CrateDB before they turned up to GrafanaCon? Oh, sweet. Okay, cool. Who's used CrateDB? Okay, not so many. Okay, so hopefully we can adopt a few users today. So CrateDB is really aimed at machine data. It's a distributed database and brings the kind of like the NoSQL kind of scaling that we expected from sort of like modern databases and modern data stores over the last sort of decade or so. But with the punchline of actually being a SQL database, including all of these things from SQL that you know and love and expect. So, for example, joins. We like pretty much any form of data you'd like to throw at us. Structured, unstructured, time series, blob data, geospatial, you name it, we love it. We love working with it. And that really is Crate in a nutshell. It is, quite frankly, it is simply a database. But it's a pretty awesome one, and I hope by the time I've finished sort of demoing it over the next half hour or so, you'll get a feel for why it's, why I love it so much. A little bit of historical context. I'm assuming most of you have seen this diagram before. The amount of data we're producing as mankind is growing rapidly, exponentially. The amount of data that machines are producing is growing way, way faster. And if you look around, a lot of the talks that have been going on here at GrafanaCon have really been about, things like, network monitoring, that kind of data, or server monitoring and that kind of data. We're going to see this thing, I don't know like a trend, I guess, over the next, say, decade, where, most of the data that's being generated is really coming from machines talking to machines. It's which, at least I live in Germany, it's something in Germany we're calling Industry 4.0. I don't know if that's a buzzword that's made it into the United States yet. But there is, so it's not, I'm sorry, it's not the last buzzword that's coming out in this talk. So we're really going into this age now where we have, people aren't producing data. It's the machines that people built are making data, and they're making data at rates way faster than we can appreciate. And that data has to be stored, and that data has to be analyzed. And that's what CrateDB is all about. So we get all of these kind of like modern scalable distributed database goodies that we kind of expect. But it is a SQL database. We had this kind of like this just industry disruption, right? So way back when everything was in black and white, databases like Vertica and Splunk came onto the scene, Bigtable as well, and they really shook up the way the data store, the database world worked for numerous reasons. But one of the things was they took out this model of if you want your database to perform better, you just need to put it in one big, fat, almighty machine. Get as much CPU, get the fastest disk, get the fastest network you can. And really turned that into this, they really kind of flipped on its head and started talking about like distributing the load and enabling you to work with more commodity hardware. The time after that, no real sort of like, that was the big shift, right? That was the big thing back in, say, like 2003, 2006. That was the big shift. What happened after that, of course, was this period of maturity. All sorts of like really awesome data stores appeared. Like, you've got like Mongo, Couch, Elasticsearch. All of these really great technologies came out in that period. And at that point, they're not really doing anything. Exciting or industry changing or anything like that, but they're all part of this momentum of the shift in how we store data, and they really went through this period of like maturing that whole industry, right? I don't think at that point any one store really did anything, earth-shattering, but they really made a new sort of like database paradigm, sorry, buzzword, and they really matured that market. A few years later, you start to see the first signs of sort of like discontent with this now nicely mature market. And one of the most common complaints was the we threw the baby out with the bathwater argument. We went through a phase where we matured the market, we did all sorts of things. And I think one of the things we did, and this is, I liken these two happenings together, we lost transactions. We gained a lot of other stuff as well. But most of these databases have a switch away from transactional to being eventual consistent. That allows a lot of scaling, allows a lot of speed. You get all sorts of benefits, but the trade-off is transactions. And when transactions were lost, for some reason, this seemed to, in people's minds, mean that was let's get rid of SQL as well. This is why we have CrateDB. There's a lot of people out there who want the speed, they want the scale, they want the power and effectiveness of a distributed search engine, a distributed database, but they still want to talk SQL because that's what they've been doing since forever. And you don't necessarily want to rewrite your application layer in order to make use of that shiny new data store. And this is the problem, really, that CrateDB exists to solve. And it's about bringing together these best of both worlds. It's not a transactional database, like I said, but it brings other things to the table. So, for example, whilst we don't have transactions, we do have SQL. We do have the features of SQL that you know and love. So, for example, there is support for joins. Not at the moment, but in future, we're going to be working on stored procedures. Other features are the things you expect of a normal SQL database. And I mean, I can't sell this enough. I mean, at the end of the day, Crate is a normal SQL database, at least from the perception of the user. Under the hood, it's doing some amazing stuff, but to the outside world, it is a SQL database. What this allows us to do is, while we focus on the database itself, is this allows us, because of SQL as a payload and because of using, so for example, we use the Postgres wire protocol. You can talk to us over HTTPS as well if you would like. This enables all sorts of great technologies to work on top of or underneath of the database. So, I'm here at GrafanaCon for a reason, and I'm going to be talking about Grafana and its relationship with Crate in a moment. But it allows this really nice, rich ecosystem of applications for data insertion or for apps for visualization or other methods or reasons for pulling data out of the database. So we, in this case being Crate.io, really care about the database itself, but we partner up with the likes of Grafana Labs and other companies and other open source projects in order to create a rich experience around the database itself. Which is stark contrast to others in the market which have their own tight stack. Not that you can't have other applications running with those stacks, but your expectations, especially as an open source community, for your ability to work with those projects is, you got to set some expectations. So what makes CrateDB great under the hood in terms of how it actually works? CrateDB is a NoSQL, shared nothing architecture. So unlike, say, like MongoDB, for example, there's no concept of a master node. You can connect to any node in your cluster and perform any kind of operation, any kind of query, any kind of insertion anywhere in the cluster. Every single node keeps a record of the overall state metadata, which is great for resilience of the cluster, not necessarily just the data itself. So if at any point, as can happen, you just lose a node, no problem. Your data's all still there, and the cluster knows which data is now unreplicated. And it will just happily just go about doing its thing and get the replication level back up. By default, all your data is replicated once, but you can configure that on a per table basis. So if for whatever reason you would feel more comfortable with 2, 3, 4, 5, depends on how many nodes you've got, you can up that number. If you really want, you can up the number all the way up to the number of nodes you've got. I mean, at which point you're sending a lot of network traffic around, but you're guaranteed to have all your data everywhere. Performance comes from being columnar. Data is on disk, but indexes live in memory. And this is one of the things that allows us to have very high performant queries. Not too long from now, I'm going to do a demo over billions of rows of data, and you'll get a feel for like how quick it can respond to large data sets like that. And yeah, as I said before, we like all sorts of different data types. So there is blob data support, time series data, of course, important for Grafana, and I'm going to do a demo of that. And geospatial data as well, for which we have specific scalar functions for doing things like finding the distance between 2 points. A little bit more detail on the SQL itself. It is standard compliant. There are a subset of extensions that we have that are crate specific. I don't think that makes us any different from pretty much any other SQL database. Joins are in there, arrays, different types of data again. The one that's probably worth mentioning, because I think I've covered at least most of these at some point already, is the unstructured data. So your schema is completely flexible at the time you do an insertion. So if you declare a few columns in advance and then start inserting data and the schema changes, the database will just accept that. You end up getting null values effectively for the columns on data that you've already inserted. But as you insert, if your schema changes, then the database just reacts in real time, and you don't have to you don't have to do anything with the schema manually. The database is very flexible about the data you insert, which is pretty good, especially, like I mentioned before, in this kind of like a machine-to-machine environment. You don't necessarily know what those machines are saying to each other or what kind of data they're passing around. So it's very useful to be able to just import anything and just update. As you might expect, so we have our own shell that supports the crate-specific bits of syntax that I briefly mentioned. And we have an administration user interface that gives you some information about the load on the cluster, which nodes are actually available, and so on. And we're going to take a look at that briefly. So I really want to show off what the database is actually capable of. And so I've got a couple of data sets that we're going to briefly query before I start getting to the Grafana angle, just to give you an idea of how the database performs. So the first of the two data sets we're going to briefly look at, who here is actually a New Yorker? All right. Do you know the 311 service? You ever dialed the 311 service? Maybe dig deep enough and see if we can find your phone call. So for those who aren't really aware, 311 is kind of like low priority 911, right? It's like the non-emergency emergency line. You can phone up and complain about heating or potholes in the street or cats stuck up a tree and stuff like this. Since 2009, New York, the city of New York specifically, has been publishing the records of these phone calls. So not the actual phone call itself, because of course there's a data protection issue there, but the metadata of the issue that has been complained about. So out of about 100 million plus phone calls, there's about 24 million records. So the average real world incident seems to generate about 4 phone calls. So we're going to take a quick look at this. The other thing we're going to take a look at just now is also since the beginning of 2009, all records of every single yellow cab ride have been published as well. So both of these sets are updated monthly. For the yellow cab, this is GeoPoint for the start location, the drop-off location, what was the fare, what was the tip, what was the method of payment, the number of passengers. This is all published. This is all published data, and we can learn some pretty cool stuff from this. So I want to just quickly now just switch, just show how the database performs, give you an idea of the kind of things we can learn from this data. So the crate shell is called Crash. I think whoever came up with that name is very deserving of a lot of beer. Okay, so the first thing we take a look at here is if we just do like something super simple. told you this was live. With typos everywhere. So let me mentally insert some commas for you there. So this is the almost 1.1 billion taxi rides that we have the data on. If I do the same thing for 311, then we'll see, right, this is just over 24 million 311 incidents. So when I first looked at this data, one of the first things I wanted to learn was basically, as someone who, like, you know, I'm a British guy who lives in Germany. I have no idea what New Yorkers complain about if they have a service to, you know, in neither Berlin nor the UK do we have a service where we can just phone up and complain about stuff. So the first thing I wanted to do was just kind of find out, like, you know, what do New Yorkers complain about? So we can. There is actually, they actually gave us a column for this, which is rather handy. Actually, let's also do this. Do find the top 10 things that people complain about. What did I do wrong there? No, I don't want that distinct anymore, that's why. Nor do I want that full stop. See, I told you it was dangerous. Okay, so here we go, right. So most complained about things: heating, plumbing, street condition. People complain about plaster, okay, all right. If we do actually do the first one I was going to do, because this is great. This is a real insight into the mindset of New Yorkers. Okay, so here's absolutely everything that gets complained about. The one that I always love is somewhere in here. Like one of these is squeegee, which I assume is people complaining about, you know, the guys, you know, cleaning your windows. Where was it going? So there's the heating one. Yeah, trapping pigeons is great. Yeah, I love this. You can complain about complaints, apparently. Oh yeah, that's the one I really love. Opinion for, like, I want to give the mayor a piece of my mind. And we can do other things like, you know, we can find, like, you know, how many. How is that done? I think it was like that. Oh, the borough's never. So I can't. Okay, right. So if you phone to complain about the mayor, then the borough is never. We can at least do this. Any guesses which borough makes the most complaints? Anyone? Queens or Brooklyn? So the great borough of Null comes in second. Yeah, right. Brooklyn, Queens. These are, I don't know. These are roughly in order of population, right? This is kind of like, this is proportional to population, roughly. Yeah, this kind of makes sense. Okay, cool. So this is just an idea of, you know, if you have a large data set. So this is we've mostly been playing with the 311 data. If I do something like, what can I do with the yellow cab data? The yellow cab data, when I get to demo and Grafana, then we'll do the yellow cab data, because we can do all sorts of wonderful things like find out the average tip per hour of the day and stuff like that. So really what I wanted to get across today is, as of now, I'm proud to say we do have a CrateDB data source for Grafana. This was the work of the guys at Grafana Labs, for which we are very, very grateful. And after today, if you have the opportunity, please go and have a play with CrateDB. Please have a play with the CrateDB data source. Let us know what you think about it. Let us know what you like about it. If you want any changes in there. It is like complete support for all of CrateDB's features, and of course for everything you would expect out of Grafana as well. So really, I'm not about to say that. There's a lot of talk. It's incredible how many databases are presenting here at GrafanaCon, and there's always a trade-off between what databases are good at or what databases are bad at. Crate's particularly good at time series data, which makes us a very nice fit, of course, for Grafana, and why we put some love and attention into the data source. Today, I'm going to be showing off. This thing for those who can't, at the back who can't see it. This is a Gantner Q-Bricks with a Q station inside it as well. This is basically a data acquisition device. It fires out readings of various sensors at 100 kilohertz. And in this case, we're able to connect it directly into CrateDB, and then we can then put Grafana on top of all of that to then see what's actually going on in terms of the sensor data. I did actually bring this from Germany to the United States in my checked luggage. I found lots of paperwork inside my suitcase when I got to the airport at this end. So let me show you what's going on inside here right now, give you a feel for how this device works. But here's the most important thing. So I've got my sensor array set up here. The CrateDB in this case is actually running on this machine right now. I've got a single node running right here on the laptop. So this box is just talking directly to localhost, and then I have to provide it a few other pieces of information, like which schema, which database is actually talking to, table name, and everything else you'd expect from a data source plugin. So now what I can do is if I create a new dashboard here, just check I've got the right. Okay, so here I'm going to check my sensor data, and if I pick the one I find most interesting, so for example, if I pick not the temperature, the tweezer, if I put the tweezer value out here, and I don't want the last 6 hours. Let's go for the last 10 seconds. That's a function of the resolution rather than. Oh right, yeah, we're gonna play with this anyhow. So we'll. So this is what's going on for the. This is what's going on with the tweezer sensor I've got here. Like I said, last 10 seconds. So if I just grab this thing, you should be able to see what I'm up to when I start doing things like this.
Is this the strain gauge?
Yep. Yeah. Or if I grab, do that, the one thing that I was always told never to do with the sensor. So you can see all sorts of sensor data coming in and out here. If I just add, for completeness sake, if I add another one.
This was 100,000 points per second?
That's not what the box is doing right now, because it's only one node. It's only literally just this laptop, which is busy doing other things as well. But yeah, this device can do 100 kilohertz. Right now, it's only doing 10. But it can do 100,000 if you want it to. So just for the sake of completeness, I can now pick another sensor.
Can it do that over the network to Crate, or is it store it locally in Forward?
No, it can. I mean, actually, that is what it's doing, right? So this is actually talking Ethernet to this machine, over Ethernet to this machine here. But yeah, normally this would talk to the database over there somewhere. The only reason it's doing directly here is just to reduce room for cock up in a demo. So the other one that's kind of funny is if I pick the temperature sensor. So the second one here is the temperature sensor. So 19, so we're basically like just under 20 degrees Celsius, which in Fahrenheit's what? That's like 70, something like that. Something like that. And what's fun with that one is you can see like presenter nerves at play, because if I now grab this thing, you're gonna watch it just go. Yep, there it goes. And that's I always find this one's badly calibrated. I want to find this freaky because it goes way up and above normal body temperature. But there you go, right? So there you go. You get a feel for this is data going in and coming straight back out again only a couple of seconds later. And just like you would normally expect with Grafana, I can take a subset of that and grab just that time period, or just this fraction of a second here, and see what's going on inside. And I hear clapping next door, and I think that's about it. So the final thing I wanted to do very briefly was a couple of thank yous. Again, a big thank you to everyone at Grafana Labs for their help with getting the data source going. And also a big thanks to anyone from Packet in the room. The cluster which hosts the New York data, the CAB data, and the 311 data is hosted by Packet for us. So we're really grateful for their support as well. And thank you for coming along. Thank you very much. Right. So so we don't have any kind of aggregation like that. At the moment, we just have like this is a product which comes with so I was just demoing version 0.57, by the way. Right, so no, at the moment we don't have support for that. Like for things like downsampling, we don't have support for that. This is very much on a, it doesn't exist right now. With a certain level of authority, I'd say you should expect it to be enterprise licensing and support. But this doesn't exist right now. Right now, we very much care about growing the ecosystem. So it's an Apache 2 project, right? So we very much care right now about just getting users, building the community around it. Monetizing the thing, of course, is something that will be important to us, but it's not necessarily top priority right now. Yeah, absolutely. So all forms of joins, inner, outer, left, right, you name it, we got it. SQLite? No, absolutely not. There's zero indexing there, for example. So if you do any kind of select with a where clause on SQLite, you end up parsing every single row. Even in memory, that's a very slow operation. So I always get in trouble for saying this. I personally don't even really see SQLite as a database. It's a SQL interface to storing data on the file system, basically. So no, I don't particularly see SQLite as a competitor, although only in very, very specific use cases. Certainly not enough to concern. But the competitors really are all of the other NoSQL databases that have this kind of scale. Elastic, Mongo, Couch, right? Those are the competitors. Splunk, Vertica, right? Those are the competitors. And actually, as the market shifts, right now when people think about databases, they still think about transactional databases. I think over time that's really going to shift, and at some point, competitors actually end up being Postgres or MySQL. No and yes. So no GridFS, and yes, there is an ODBC, there's JDBC, any driver that talks the Postgres wire protocol. Yeah. Because of the crate specific flavors, for many purposes you probably want to use the crate JDBC driver, for example. But the standard Postgres JDBC will also just work for simple selects, for example. Like in terms of nodes? So yes, definitely. We've pushed it to 1001. But it's a gossip-like protocol. So all nodes are talking to each other all the time. So in true practicalities, things started to kind of get a bit hairy around about 500 nodes. And to be honest, the number of real-world applications that require something that size, well, they probably exist. But certainly, so the demo I just did was only 8. And I think we know of in production clusters in the 20s. But yeah, we've pushed it to 1,000, at least we know the nodes can actually talk to each other, but they can't really do very much. But up to about 500, you still get performance. We were the only player in that market. Yeah, we were the only player in that market till about yesterday, I think, because Amazon just moved into it. It really boils down to, I'm assuming everyone in this room speaks SQL, right? All of these, the new data stores, the new databases, for various reasons, and for reasons that did and still do make sense, typically went for some kind of API that involves pushing JSON backwards and forwards. It does make sense. It still makes sense. But you have a whole raft of applications out there and engineers out there who know and understand SQL. There is a massive market just in human terms, and not forgetting also the technological benefits of when you have like a columnar store, the mental hoops that you have to go through to turn that into something which actually talks SQL are not all that great. It's a lot of effort, but for whatever reason, a lot of databases just decided not to do that. Despite the entire raft of people in the planet who understand this language, who have applications already out there already speaking this language. We were kind of by ourselves until literally, like our positioning was really validated by, was it 2 days ago? AWS reInvent, Amazon have just put SQL support on top of S3. I wish we were the only ones, but certainly we were one of the first to realize that there is a huge market here for putting SQL on top of these scalable databases, basically. Are we good? Thank you all.